I'm Algebra Annie, and I am here to help you be successful in your algebra class. With new day comes new strength and new thoughts. Eleanor Roosevelt. Our learning targets today are: I can graph functions given in a limited domain. I can graph functions given a domain of all real numbers.
So now we are going to be graphing functions. So this is our first problem. They want us to graph the function with this given domain. So our first step is always going to be that we need to solve for y. I will not be able to interpret this equation, this function, and fill out a table if I don't have my equation already solved for y. So the first thing I need to do is solve for y. So this is the equation that they gave us. So the first thing we need to do is we need to add x to both sides. That gives me 2y equals 6 plus x, so 6 plus x. And I need to get y completely by itself. So I'm going to divide everything by 2. So I needed to get y by itself. 2 divided by 2 is 1, so I have 1y equals 6 divided by 2 is 3. This was technically a 1, so we have a positive 1 divided by 2. Positive 1 divided by 2 is the same thing as 1/2, and that was the fraction that was stuck to the x. So we went ahead and solved for y. We always like the x part to be written first, so y equals 1/2 x plus 3 is going to be this equation when we solved for y. So step 1 is to solve for y. Now that we've already gone ahead and done step 1, we need to move on to step 2. Step 2 is to fill in the table. This is our table over here. The first column in the table is always our x coordinates. The middle part of the table is always the rule, so we found that the rule is y equals 1/2 x plus 3. And the last part of the table is always the answer of the xy coordinate point. It's the point that we will be graphing. This is going to tell us what the answers are in the end. So step 2 is always to fill in our table. So we have a domain. If you remember, we wrote domain to look like this. And we wrote domain because domain always helped us with the numbers on our x-axis. So we know which x values we're supposed to use. So these are the x values that they want us to use in our table. So -4, -2, 0, and 2 are the x values they are telling us to use. Now we have to use each of these x values, and we need to solve for y. So looking at this, I am given the x value of -4, which means when I am plugging that into my rule, this x is going to change to -4. So I have the rule y equals 1/2, and then I need the new x value. My x value is -4, and then I'm supposed to add 3. So this was the x value that was changing every single time. If we did it to the other one, we have a new x value of -2. That is going to be the new highlighted number, because every single time the highlighted number is going to be changed. This was our new highlighted number. Same with the other row. If I am given an x of 0, that means in this rule, I wasn't going to write the highlighted x. The highlighted x is going to be 0. So there is my highlighted x of 0. Same with the last one. Y equals 1/2. This was always the highlighted number in here. For this row, x is supposed to be 2. Our highlighted number is supposed to be 2. So my highlighted number is supposed to be 2. So this is how you would plug the number into the equation. And now you need to do your order of operations and actually solve for the individual equations. So way back up here, y equals, order of operations, say multiplication needs to go first. So 1/2 times -4 is a -2, and then we still need to add the 3. So y equals a -2 plus 3 is a +1. So y equals 1. So my answer is, when I used -4 as my highlighted number, I got an answer of 1. So we have our first coordinate point that we need to plot onto our graph paper. Moving on to the second coordinate point, y equals 1/2 times a -2, well, positive times a negative is a negative. 1/2 times 2 is 1, so this is a -1. We still need to add the 3. Y equals -1 plus 3 is a +2. So when I plugged in -2 to my highlighted number, I got an answer of 2. So my xy coordinate point is -2, 2. Going on to the next one. Y equals 1/2 times 0 is 0, and then we're still supposed to add that 3. 0 plus 3 is 3. So when I plugged in 0 to the highlighted number, I got an answer of 3. So my coordinate point is 0, 3. Last one, y equals 1/2 times 2 is 1. And then we're supposed to add the 3. 1 plus 3 is 4. So when I plugged in 2 to my highlighted number, it gave me an answer of 4. So I have the coordinate point 2, 4. So now that we have our table, the next thing we need to do is that we need to plot these onto a coordinate graph. So step 3 is to plot onto a coordinate graph. So we have our graph paper right here, and we need to plot our XY coordinate points. So the first coordinate point is -4, 1. So there's that. Then we have -2, 2. We have 0, 3. And we have 2, 4. So we went ahead and we plotted on the coordinate graph. Now step 4, you need to be very careful. Step 4 is you asking yourself, do you need to connect the points? And to do that, you need to check your domain. The domain tells us when we connect and when we don't connect. So do we connect? I'm not quite sure. We need to check our domain. So we were given a domain, which means we were given exactly which x values they wanted you to use. They did not want you to use any more. They did not want you to use any less. They wanted these 4 exact x values. They don't want anything in between, or there would have been an inequality in here. They only want 4 points. So we only want 4 points. So we are not connecting. So we are not connecting because the domain states only 4 exact points. If you were to connect these, you would be saying everything in between was an answer, and that makes infinite amount of answers. We only wanted 4. So here is our 4, and you're done. So moving on to our next question, we're being asked to graph this function, and we're going to do it with a table because I don't know how to graph this particular function. So step 1 is always to solve for y. So our job is to investigate what problem did they give us, or what function did they give us. So the original function they gave us was f of x equals the absolute value of x. Step 1 is to solve for y. I don't have a y, I have an f of x. Well, if you remember from our previous lesson, f of x is the same thing as y. So this problem is technically already in a y equals problem. So we're basically already done. Yes, this is already in a y equals. You can now move on to step 2. So our step 2 is telling us that we need to go and we need to look at the table. We need to fill out the table. So coming over to our table, the first column in your table is always your x's. The middle column in your table is always the rule. Our particular rule is an f of x equals the absolute value of x. And then the last column in the table is always your answer. Now usually it's an xy coordinate point, but we don't have a y, we have an f of x. So this is an f of x coordinate point. It's the same thing as y. So what do we put in for our values for x? Well, they gave us a domain. If they give you a domain, you have to use those numbers for x. So we need to use -2, -1, 0, 1. My table was too small. I need to fit all of them, which means I need to fit 2, which means I need to make more room. So paper goes up. Here's me making room. 2 needs to fit as well. So there, 2 fits. So the next thing you need to do is I need to actually do my equations. So looking at it, the x is going to be changing each and every single time. So for this first row, -2 is my x value, which means all the highlighted numbers, this x is going to change, and this x is going to change because those were all x values. So -2 is going to be both of those highlighted numbers. So there it is, -2's. So the f of -2 is just a fancy way of saying we are solving for this function, and we're solving when it's -2. So you are not doing anything to this side. This is just kind of telling you what we're doing. This is the math problem. What is the absolute value of -2? The absolute value of -2 is a +2, and you're done. So when I plugged in -2 to my equation, I was given a final answer of 2. So my coordinate point is -2, 2. Well, now I need to repeat it for x being -1. So the rule is f of some highlighted number equals the absolute value of that highlighted number. So these are going to be the same exact number because they're both x's. This x is a -1. F of -1 is just telling us what we should be doing. We're graphing or solving for the function and using -1 as our number. So the math part's over here. The absolute value of -1 is 1. So when I plugged in -1 to my green highlights, I got an answer of 1. Now if we go ahead and we do it for the others, the highlighted empty spaces are now zeros. So here's me plugging in zeros. The absolute value of 0 is 0. So when I used 0 for my green highlight, I got an answer of 0. Moving on to the next one. This is the way the problem is written, and the green empty highlights are the numbers that need to be changed. This highlight is supposed to be 1, so these numbers are ones. What is the absolute value of 1? That's 1. So when I plugged in 1 for my green highlight, I got an answer of 1. Last one, these empties were the highlighted numbers that got changed each and every time. This time, 2 is the number that we need to put into those empty highlights. What is the absolute value of 2? That is 2. So we have the coordinate point 2, 2. Now you've done your table. You need to move on to step 3. And step 3 is to plot the points. So if we are plotting points, then we actually need graph paper. So here is our graph paper. And I am given the coordinate point -2, 2. So -2, 2. -1, 1, 0, 0, 1, 1, and the coordinate point 2, 2. So I went ahead and plotted all of our coordinate points. Now the next step is step 4. And step 4 is you asking yourself, do you connect? And to see if you actually connect or not, you need to check the domain. The domain tells us what we should be doing. This particular domain says they only want 5 distinct separate points. 5 distinct separate points. I don't want anything in between. If I highlight or if I go ahead and draw a line in between, they're telling me that there's infinitely many domains. There's not. There's only 5 distinct separate points. So all I want is 5 distinct separate points. So no, we do not connect because the domain lists only 5 separate points. If we were to connect, the answer would have been infinitely many points. So moving on to our next problem, they want us to graph this function in this using this table. So step 1 is always to solve for y. So the equation they gave us was a -2x plus 1 equals y. We're supposed to solve for y. We're supposed to get y by itself. Y is already by itself, but it's not on the side of the equal sign that I like it to be on. So we're literally going to pick it all up and flip-flop it like we learned in chapter 3. So if this side says y, this side says y. This says -2x plus 1. This side is going to say -2x plus 1. It's the same exact problem, just I like it when the y is written on the left side. So we're done with step 1. Step 2 is for you to fill out the table so we know what points we're supposed to plot. The first column is always our x's. The middle column is always the rule that we will be using. So y equals -2x plus 1. And the last column is always the xy coordinate point that we will be using to plot onto the graph paper. So far, we've been given domains and we've been filling those in. This time, they don't give us a domain. So if you don't have a domain given, you pick your own points. So if no domain is given, you need to pick your own x values. I like to stick with -2, -1, 0, 1, and I actually like to fit in a fifth one. I always like to squeeze in 2. I always like to do these 5 because these 5 help to give you a general idea of what shape your graph is going to take. So the x values are always the numbers that we are going to be using and replacing, substituting into our rule. So our rule has the x value right there. So this is going to be the x value that changes every time. So for some students, it's easier to write it already on every row as a blank so they can remember that that is the number that will be changing each and every single time. So in every single one of these, this is the number that is going to change each and every single time. So in this row, the green highlight's a -2. In this row, the green highlight is a -1. In this row, the green highlight is a 0. In this row, green highlight's a 1. And in this row, the green highlight is a 2. So now we just need to go through and actually do our algebra. So y equals, order of operation says multiplication goes first. -2 times -2 is a +4. And then we're supposed to add the 1. 4 plus 1 is 5. So when I used -2 in my green highlight, I got an answer of 5. Moving on to the next one, y equals, -2 times -1 is a +2, and we're still supposed to add the 1. 2 plus 1 is 3. So when I used -1 in my green highlight, I got an answer of 3. Moving on, y equals, -2 times 0 is 0, and we're still supposed to add the 1. 0 plus 1 is 1. So when I use 0 as my x, I got a y of 1. Moving on, y equals, -2 times 1 is a -2, and we're still supposed to add the 1. Y equals, -2 plus 1 is a -1. So when I used 1 as a green highlight, I got an answer of -1. Y equals, -2 times 2 is a -4, and then we're supposed to add the 1. -4 plus 1 is a -3. So when I used 2 as my green highlight, I got an answer of -3. So now that we have our 5 points, we need to go ahead and do step 3, which is to plot the points. So step 3 is to plot. So if we are plotting the points, we need a graph paper. -2, 5 is our first point. -1, 3 is the second. 0, 1, 1, -1, and 2, -3. So here are the 5 points that we found. Now the last step, step 4, is for you to check and see, do you connect? And to figure out whether you connect or not, you need to check the domain. So I was supposed to check my domain. I am looking, and I wasn't given a domain. I had to pick my own points. If you are not given a domain, that means that you need to connect the points, because that meant any x value could have been used and could have been tested. So you need to connect all of the points. So this is what our line would look like for this rule. So yes, we ended up connecting our points. Why? It's because we ended up picking our own domain. When you pick your own domain, you need to connect your points. Our last graphing example for today, they want us to graph this function. So step 1 is always to solve for y. Looking at what they gave us f of x equals x squared. They didn't give me a y. They gave me an f of x. Well, if you remember from a previous lesson, y and f of x are kind of interchangeable. So it's already in y equals. So yes, we're done. You can technically move on to step 2, which is to put it into the table. So the first column in our graph, the first column in our table is always the x's. The next column in our table is always the rule. This particular rule is f of x equals x squared, because you found it right there. The last column is always the coordinate point. Well, it's not an xy coordinate point because we don't have a y. We have an f of x. So this is an f of x coordinate point. Now we're looking to see what we put in for our x values. I'm not given a domain. If you're not given a domain, you pick your own points. So what points do you want to pick? I like to pick -2, -1, 0, 1, and 2. These give me a general idea of what the graph should look like and kind of the pattern that I would see. So these x values are the numbers that we'll be putting in for x. Here is where x is in our rule. So f of whatever my new number is going to be is equal to the entirety of whatever that number is needs to be squared. So I'm going to write that rule in for each of them so I don't accidentally mess up and accidentally invent a new equation later on down the road. So this was supposed to be a new number and that's supposed to be a new number. So it looks like the insides of all of these parentheses are supposed to change each time. So -2 is supposed to be these x values. So -2 is those x values. F of -2 is just the way of saying we're graphing a function and that function is being tested at -2. We do not do any math over here. There's no math to be done. All the math is on this side. So the quantity of -2, that all raised to the second power, is technically -2 times -2. If I had -2 times -2, I ended up getting a +4. So when I used -2 for my green highlight, I got an answer of +4. Now we need to do the next one. The green highlight is -1. The entire quantity of -1 raised to the second power is technically this. This parenthesis was 2 times, so the parenthesis is 2 times. -1 times -1 is a +1. So when I used -1 for my green highlight, I got an answer of 1. Moving on, the next green highlights are supposed to be zeros. 0 to the second power of 0. So when I plugged in 0 for my green highlight, I got an answer of 0. The next one, 1s, are supposed to be my green highlights. 1 to the second power is 1. So when I used 1 for my green highlight, I got an answer of 1. Green highlights are supposed to be 2s. 2 to the second power is 4. So when I used green highlight to be 2, I got an answer of 4. So I now have 5 points that I need to graph, and step 3 is to plot those points. If we're plotting points, we need graph paper. I need to plot the point -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So this is what my graph is starting to look like. Step 4, you're supposed to check whether or not do you connect. And what tells you to connect is when you actually check the domain. We were not given a domain. We had to pick our own domain. So if you have to pick your own domain, yes, you connect. So yes, we're going to connect because we picked our own domain. Now, something very special about this graph, you will see that there is no way to connect these 3 lines, these 3 points, all on the same line. There's no way to connect them. Please do not connect it so it looks like a rocket ship. You are not going to be connecting these really straight and then those really straight. If you cannot connect with a straight line, it's because it's meant to be a U-shaped parabola. So make it look as close to a U as you possibly can. So yes, this is supposed to be a U shape. It's not a rocket ship with straight edges. It's not a V. It is a U. So the last thing that we are doing today is, can you go backwards? If I gave you a graphed line, could you tell me what those XY coordinate points were? So this graph starts off by giving you 4 points that they would like you to try and label. But notice our table has 1, 2, 3, 4, 5 spaces. So I need a 5th point. I really like it if I'm allowed to pick any one I want. I like it when they pick at a nice exact corner point. So that's going to be my next point that I'm going to pick. So looking at this, I picked a point of 1. So my first had an x of 1. Now at 1, where did it hit the y-axis? I'm going to have to guess. It looks like it hits at about a 1/2. So here is 1/2. The next dot I chose, the next point, was at 2. So here is my 2. And where did that reach on the y-axis? That reached at 1. So the coordinate point 2, 1. So now this coordinate point. It was the coordinate point 3. And how did it reach across on the y-axis? That looks about 1.5. This coordinate point, it was on the x at 4. And where did it reach at the y? It reached at 2. Now I picked this one next. It reached 6. And at 6, it went across and it touched at 3. So this graph had at least these points. Yes, it was connected. We didn't list a domain or anything, so it's okay. I just had to list 5 coordinate points, and you're good.
What did we learn today? I can graph functions given a limited domain. I can graph functions given a domain of all real numbers. And I look forward to seeing you tomorrow in class.